Moving into section 11.4, in our last video we were working with all right triangle stuff, so now the next part of this is to move into non-right triangles. So we get into things like the law of sines and the law of cosines for non-right triangles, and so that's what all this is dedicated to. Not that these things don't work for right triangles, because they do. We just tend not to use them because there are easier ways when you have a right triangle. And so these are the methods, though, that we fall back on when it's not a right triangle. So to use the sine rule that you see here, so you probably learned it as the law of sines. IB calls it the sine rule. It's going to be the same thing with the law of cosines. They call that the cosine rule. These are in your formula packet. So real quick, you got a couple formulas right here that you're going to use for this chapter. So these two you've seen before. This is what we used to call the law of cosines. This would be the law of sines, or the sine rule that we're looking at right now. And this is for finding the area of any triangle, but we specifically use it for non-right triangles just because it's kind of the only way to do it for non-right triangles. Anyway, so getting into the law of sines, one reminder, and I didn't mention this in the last video, but something you always need to keep in mind: make sure your calculator is in degrees whenever you're doing sine, cosine, and tangent stuff. That's a really common problem because in cases like tests or finals, IB tests, things like that, where you do switch back and forth between radians and degrees, that can be a problem. So make sure that your calculator is always in the right mode when you're doing these. But simply put, the sine rule is a proportion. So you're never going to use all three of these at one time. You just need two of those. We are setting up a proportion. In one ratio, you're going to have both things that you do know. So the capital letters that you see here all represent angles, and the lowercase letters always represent the side across from that angle. So for example, if we're going to call this angle A with a capital letter, the side across from it would be lowercase a, and so on and so on. And so with one of these ratios, you have to know both of those. So you have to know an angle and the side across from it. In the other ratio, you just need one of the two, and then we'll put an X for whichever one we're trying to find, and we're good to go from there. So the sine rule works as long as you have one complete ratio. You need to know an angle and the side across from it in order to use the sine rule. And so that's where these guys come into play, but you really don't need to memorize that as long as you understand that in order to set up this proportion, one of these ratios must be complete. So somewhere in there, I do need an angle and the opposite side in order to set up a valid proportion here. Anyway, moving on, here's one example. So you can see what was given to us. We got a couple angles given, an unknown side, a known side. So one of the things we could do right off the bat is recognize some just basic triangle rules. Angles still have to add to 180. So if I subtract from 180, I get my third angle. That's always something you should look for. But now we can use the sine rule because now I do know an angle and the side across from it. And so we're okay to go ahead with the sine rule. So in this case, keep in mind this is not a right triangle, and so this is why we need things like the sine rule. You can't use SOHCAHTOA if it's not a right triangle. So if we go ahead and set up our proportion, so I have a known ratio. So this is my complete ratio right here, where I have a side and an angle across from it, and then I have on the other side, I have a ratio with an unknown. So here's the angle that we do know. This is the missing side across from him. And so that's how we set this thing up. And from here, it's just cross multiplying. So I'm doing x times this would equal 35 sine 65. And then if I want to get x by itself, I would just be dividing that back over. So cross multiplying is a pretty easy way of looking at this. Whatever approach you take, this is what it's going to look like when you get x by itself. So all that would go in your calculator, and we got our winner. Do keep in mind that even for this, if you are solving for an angle, so let's just say for a minute that you knew x was 46.5. So let's just say you knew this was 46.5, but we're calling this sine A, and we didn't know what this was, and we were trying to find an angle. Well, you would still cross multiply, but in the very last step, you would have to do an inverse sine in order to get your angle. And so anytime you're looking for an angle, you still do an inverse trig function to find it. All right, so there is one case that's always a little weird when you get into the law of sines, and it's called the ambiguous case of side-side angle. So when you have side-side angle, and here's what we mean by that, I'm given a side, and an angle, and in that order. Notice that their order here does matter. If my angle of 30 were here, it would be side, angle, side, not SSA. And so if I look at these in consecutive order, I do have a side, angle scenario. So with these, the one thing you have to look for is when it comes to the drawing, if the drawing isn't given to you, we don't know exactly how this could be drawn, because if this angle is 30 and this segment is 12, we'll look at this line right here of 7. This one wasn't drawn very well, but what this means is if this length is 7, how do we know if it's drawn inward right here of 7, or if it were drawn outward right here of 7? Either way I draw that, it's the same length. So I could have a 7 right here, or I could have a 7 right here. It's the same length either way I draw it, and this angle doesn't change either way I draw it. And so how do we know which case should it be? Well, we have to consider both scenarios. If we draw it this way, that would make angle A an acute angle. And so the work that you're seeing on this side is treating angle A as an acute angle. And so if you just went through with the common law of sines approach, so you can see the work that was done here, we come out with angle A of 59 degrees. So we'd say, okay, well that's a scenario, that's a possibility if A is acute. So we'd have 59 degrees right here. So that means, our 7 is drawn a little more inward to create that 59 degrees. So if that's 59, that's 30, subtract those from 180, and we would see that angle C is 91 degrees. And we'd say, okay, those numbers make sense. If we went through with another round for the law of sines, this is what you would get for side AB is 14. I don't know why that degree mark is there, but that is a length of 14 for AB. And so here's one thing to consider, and this is the way I always know that I'm doing things right when I'm doing this ambiguous case. There's always two rules that you have to consider when you're working with a triangle. One is the angles must always add to 180, no more, no less. And so that's one rule that I always check for to make sure that I'm doing things right. The other rule is this, and this is really important for this SSA case. One of the rules that you learned with triangles is, a long time ago, is everything is proportionate, meaning the smallest side must be across from the smallest angle. The largest side must be across from the largest angle. Check that. That is one of the main key rules to help you know that you did things right when you're doing this SSA case. So if I do check those numbers, so I'm seeing angle C as my largest angle, which must mean that the side across from it must be the largest side. So if I check the numbers, yep, 14 is the largest side. And the smallest angle, which is 30, across from him must be the smallest side. And so that fits. And so I know my numbers make sense for this drawing. So let's consider the other case. What if my value of AC for 7 was drawn here instead, and that's the picture that you're seeing on this one? Let's see if those numbers make sense. One thing right off the bat is when you're doing this ambiguous case, the angle that is pivoting here, this angle A, whether it's acute or obtuse, for both cases they have to add to 180. So if we figured out that this was 59, then my other option, if I subtract 59 from 180, would be 121. And so we look at that and say, okay, well, so if this is 121, let's proceed with the problem here as though this is 121 degrees. So if that's 121, so 121, 30, subtract those from 180, and that leaves me with 29 degrees for this. So here's something to consider again. If that's 29, that's the smallest angle. My math better show that this is the smallest side in order for this to make sense. And if this is my biggest angle of 121 degrees, it better be across from the largest side. If it's not, then I throw this case out and I would only use this as my answer. And so that's what I'm checking for. So if I went ahead with the math on this, so if that's 121 and that's 29 degrees, I would use the law of sines to get AB. And that's where you get right here of 6.79. So if you check the numbers here, so 29 degrees is the smallest angle. 6.79 is the smallest side, so I'm okay on that one. That is 121. Across from him is the largest side, so that works. So because that law is still in place, the smallest side is across from the smallest angle right here. The largest side is across from the largest angle. That works. So the law is in place. So I know my numbers are good, and I would keep this as a possible scenario. So we have two answers for this. These are one scenario. This is my other scenario. Again, but check the laws to make sure everything is in place. If you do this math right and that ratio law is not working for you, if the smallest side is not across from the smallest angle and the largest side is not across from the largest angle, if any of that isn't true, you got to throw out this case and don't use it. So here's an example, this last one here, of where that wouldn't work. So look at the numbers here, and again, I do have another side angle case. So if we do our law of sines, we would see that angle R in the acute form is 15.2 degrees. So if that's 15.2, and I subtract 15.2 from 180 to get the other case, remember up top when we did this, we had an acute form and an obtuse form, and in the acute form and the obtuse form, they must add to 180. So if I can do that on this one, so if this is an angle of 15.2, if I subtract that from 180 to get the obtuse drawing of right here, that would mean this angle R is now 164.8 degrees. Well, we'd be breaking one of the laws of triangles. If R is 164 and this is 46, already I'm above 180 degrees. That wouldn't make sense. And so I would look at that and say, okay, I'm breaking one of my laws of triangles right here. So I know this is not an ambiguous case. There's only one solution for this drawing, and it has to be the acute version of the drawing. But again, you're always checking for those two rules. Your angles, all three of them, must be able to add up to 180 in order for this process to work. Also, you got to stick with the ratio law, right? Smallest side, smallest angle, so on and so on. If you look right here, look at that ratio law for a minute. 55 is obviously bigger than 20. So for all the laws to be in place, he must be across from a bigger angle than him. And so if 55 is across from 46, since this side is smaller than 55, the angle he's across from must be smaller than the angle that he is across from. And so this angle automatically has to be smaller than 46 in order for these laws to stay intact. So that's another tip right off the bat where I would say, okay, this has to be acute, right? I can't go with this because I can't go with the ambiguous case because this angle must be smaller than 46 in order for my laws to stay intact. If you consider the way this one was drawn again, because 12 was bigger than 7, I just needed to make sure that angle A was bigger than angle B in order for that law to stay intact. And because that law fit in both cases, we kept both solutions as our answer. So those are the easiest ways to make sure whether you know you should keep both or only keep one of them.